Okay, this is review of orbital notation. This is what we were working on today. Okay, so we're going to pick an element. Let's go with an easy one. We'll do boron. Symbol is B. Atomic number 5. So it has 5 electrons in its neutral state, which we're only going to be dealing with neutrals. We'll leave ions for the pre-AP class. Boron, B, 5 electrons. Now, when you're doing orbital notation, I prefer to do the electron configuration first, just because I think it makes it a whole lot easier. So this is your diagonal rule. Check out the video on that, but just real quick, it comes out to 1s2, 2s2, 2p1. So for our orbital notation, every orbital can hold 2 electrons. So that means 1s with a maximum of 2 electrons only has 1 orbital. So we're going to draw our orbital and label it 1s. 2s, still an s, 2 electrons, 1 orbital. 2s. And now p, in this case we only have 1 electron in the p, but it can hold up to 6. Now 6 electrons, 2 electrons per orbital. 6 divided by 2 gives you 3 orbitals. 1, 2, 3. Now collectively we're going to call these 2p. But individually we're going to refer to them as px, py, and pz. Okay, now remember your 3 rules. We have Aufbau, Hund, and Pauli exclusion. Shorten that to Pauli, make that look a little neater. Okay, Aufbau, Hund, and Pauli. Aufbau says we start at the lowest energy. Our lowest energy, 1s. So we're going to start there, put our first electron. Now Pauli says that they have 2 orientations. They can either have an up spin or a down spin. It's arbitrary, so I like to start with up because positivity. Why go negative if we don't have to? Now, Hund's rule says if we have empty orbitals, we have to fill them first. But in the 1s, we only have 1 orbital, so it's not empty. So we have to give him his partner. Can't have his privacy, he's got to have a roommate. Since we need 2 electrons, it goes here. But remember, Pauli exclusion says they have to have opposite orientations, opposite spins. So there we go. We have our up spin and our down spin. Now we're done with 1s. Now we'll go to 2s. Same thing. Aufbau says that's our new lowest energy. So fill it. We're going to give it an up first. Because of Pauli, it has to have an orientation. It has to have a spin. Now Hund, we check. We don't have any empty orbitals. We're just focusing on the 2 right now. So he has to have a neighbor. And then back to Pauli, he has to have the opposite. So he gets a down spin. Now for the p's, we start with the lowest energy because of Aufbau. That's 2p1. That's going to be px. Now we're going to go up. Now we have 1, 2, 3, 4, 5 electrons. This notation is the same as this, just expressed a little differently. So it's the same thing, just expressed 2 different ways. We have 5 electrons in both. That's good. Either one works. Now, we're going to put Hund's rule into practice a little more because seeing it is better. Now, whoops, I didn't mean boron. What I actually meant, oops, get my eraser. Not boron, that's crazy. What I really meant was I meant fluorine. Oh, whoa, I totally spelled that wrong. Fluorine has atomic number 9, so 9 electrons. So now we have to repair this. We're still at 1s2, 2s2, those don't change. Now we have 9 electrons. We've used up 5, which means we need to fix this. It's not going to be 2p1, it's going to be 2p5. So now we can use this, and we can go back and we can fill this out properly. We don't have to change this. This first part is still valid. We're just going to add to it. So we're going to take Hund's rule. We want to fill empty orbitals first. So after px, we have the pz, py, and pz. So we're going to put 1 in py. Now we still have an empty orbital, so we fill that. Then we go back and we start doubling up. We still have 2 more electrons to account for. Now the Pauli exclusion principle says they have to have an opposite orientation. That's 1, 2, 3, 4, 5, 6, 7, 8. Where this last electron goes is in the py. Now we're done. Take a second, write these notes, copy it down if you need to. The next one, if you feel like, press pause and try to solve it on your own. We're going to set that up right now. Okay, this time we're going to do, we did up to fluorine, let's do phosphorus this time. Phosphorus. It's atomic number 15, so 15 electrons. Okay, take a second, try to write out the electron configuration for this. S2, 2s2. Okay, now we're going to turn this into orbital notation. Take a second, try to figure that one out. Okay, now we're going to turn that into orbital notation. Again, orbitals can only hold 2, so S2. Label that one S. And we're at 2S. And then P's hold 3 orbitals because 6 electrons. And then we're going to call this 2P. And then give it your notation. Px, Py, whoops, Py, Pz. Then 3s, it's back to an s, so it only gets 1 orbital. And then our 3p. 3p is Px, Py, Pz. Okay, Aufbau says we start at the bottom. Give it a positive spin. Now we have to finish this orbital, this energy. So call it down. That's a 2. Now we go on to 2s. There's 3 and 4. Now we get to the 2p. This is where the fun starts. Start in px. It gets a 1. Then you go to py. There's another. Pz. It's another. Then we go back and start pairing them up. Because Hund says we want to fill empties first. So we filled all the empties. Now we go back and give them their neighbors. And then Pauli exclusion says we get opposite spin. So these ones are going to be downs. Down, down, down. 3s. Be an up and a down. And this is why I like the electron configuration, because it tells us where to stop. We know we have to go all the way to 3p3. We're in 3p. Now we just need 3 more electrons. Give it an up spin. Hund says we fill the empty, and now we still have 1 more empty. Now there we go. Now, let's say I made a mistake, and rather than phosphorus, oh, silly me. Oh, whoops, actually, real silly me, I didn't mean to delete that. Put that in. So we're going to change phosphorus to, what's after phosphorus? Sulfur? Sulfur. So we really should have had 16 electrons. So we change this 3 to a 4, 3p4. And now our last electron, we go from Pz back to Px, and this time it gets a down orientation. And then you do the same thing for the Ds. Since Ds can hold 10 electrons, you would have 5 orbitals. And don't worry about X, Y's, and Z's for those. We just lump them all together and call them 3D. Same thing for F's. You just group them all together and call it 4F, 5F, etc. So, yeah. If you need help, make sure you're coming to tutoring and ask. This is going to be on your test. You need to know how to do this.